I'm left with a 5, what? 5x, and then what else? Plus 3. Perfect. If you want to check yourself because you doubt Grant, you can always redistribute. That's 15x cubed plus 9x squared. I know Grant is 100% right. What can I factor out on the second problem? 7. If I factor out a 7, and what else? U squared. Okay, I'm left with perfect. And if we question Grant yet again, because we should always check ourselves, we distribute, we get 14u squared plus 35u to the 4th. So good job, Grant. And to everyone else who understood those. We were doing 7-1 last week, and there were 3 vocab terms I really wanted you to remember. What was one of the vocab terms? Ratio. What's another one of the vocab terms? Proportion. And then my favorite is scale factor. Scale factor was like with my Eiffel Tower, trying to figure out the exact numbers we needed to go from my tiny Eiffel Tower to the big Eiffel Tower. Okay, that's what we're going to continue to talk about today. We're going to make it much more, obviously we're in geometry class, we're going to make it much more geometric in this section. If you did not get to do the checkpoint last week, hopefully y'all ramble quickly enough that you get to do it today. It's supposed to be a 10 easy point grade in the 30% category. I'm going to do my notes first because I've already committed. I need to check your 7-1 worksheet. If you've not done your tiny worksheet, do not work on it while I'm talking. Just make sure I see it by the end of class if you're one of those frantic people. I saw like 2 people last week, but if you haven't done the tiny worksheet, don't do it now. You can do it at the end of class while everyone else does the 7-2 assignment. It will be okay at the moment.
I already showed you mine, right?
Your tiny worksheet?
Yeah, the one that's like half a sheet, like a little sheet, like this.
Okay, so what we're going to talk about today is similar polygons. And there are actually, surprise, surprise, 2 pages of notes. This is the hard page. And it's not even hard. I think this will be your favorite section. However, there are tiny mistakes you could make, and I'm going to point those out. So 2 shapes, like 2 triangles, are similar if they have the same angles. Their angles are congruent. And then their side lengths have to be proportional. Note that vocab term has come back. So the first thing I do when I'm given an example is I check to make sure all their angles match. If their angles don't match, they're not similar. So I look at this example, I see 1 rainbow, 2 rainbows, 3 rainbows, 4 rainbows, they all match. So now I'm going to get on the side lengths. I'm going to do 18 over 6, and that reduces to 3 over 1, or just 3. I'm going to do 15 over 5, which also reduces to 3 over 1, which is just 3. I'm going to do 12 over 4. It reduces to 3 over 1, which is just 3. And last but not least, I'm going to do 21 over 7, which reduces to 3 over 1, which is just 3. You seriously do need to check all the sides of the shape. If you keep getting the same number every time you make a comparison, that number is the scale factor. That number is the scale factor. Now, I'm going to say this, and I'll say it again later on. If you wanted to do the comparison in reverse, you wanted to do tiny shape over larger shape, you would get 1/3, and the scale factor would be 1/3. It just depends. Are we going from the real Eiffel Tower down to my tiny one, or my tiny one to the real one? We actually get to choose. Okay, are there any questions about that? The next example, we're going to do it, and then we're going to talk about what I actually want from you in life. This symbol, we've seen it on bell ringers. That's the symbol for similar. When we used to write congruent statements about triangles, it mattered about the order of the letters. The same thing holds true with similarity statements. All that's changing is instead of the congruent symbol in between, it's just the one squiggle line. What I mean by that, if you look at our next example, A should go with R. Angle A should go with angle R. And B is supposed to go with S. So angle B is supposed to go with angle S. C is supposed to go with T. And I got all this from the order of the letters in this similarity statement. That thing is called a similarity statement. Are there any questions about my list of angles? Okay, now I'm going to make a list with side links, but it's going to be a ratio or a proportion. I know AB is supposed to go with side RS. I also know that not just because of the rainbows between the 1 and the 2, but because AB and RS are the first two letters in that statement. I know that BC is supposed to go with ST. Yes, they're both the 2 and 3 rainbow side, but BC, ST, they're also the last two letters in that congruent statement. Similarity statement, not congruent. And then if I do AC, first and last letter, it makes sense it goes with RT, the first and last letter. You normally don't have to make this giant of a list in a problem. You normally just have to write this statement. But am I checking all of these things in the meantime? Yes. I first look, are all their angles congruent? If yes, I check the ratio like I did with the 3/1. If they all have the same ratio, I write that statement. Okay, that vocab term has come up again. The scale factor is this number that we're finding when we compare the side links. So, for instance, our scale factor on that top example was 3. And the scale factor depends on the order of the comparison, meaning if you do the small over the large, you put the smaller shape in the numerator, you're going to end up getting a fraction of a decimal. For instance, if we used our top example, you would have gotten 1/3. If you want to put the large number in the numerator and the small number in the denominator, you're going to end up getting like 3/1 or a whole number. It can be a decimal, but it's going to be a number bigger than 1. On Friday, I told you the problems we were doing involving like Eiffel Towers, toy cars, all that, the scale factor, we want a decimal. Today, we're okay with whatever kind of number. It depends on who you put in the numerator, because in this case, you get to choose. Is that what? It's okay. Just don't flip out if you get a whole number. Okay, flip over. This problem is written poorly. It's supposed to be about Tan, he's designing a new menu for a restaurant where he works. This is supposed to be the original. In fact, they've made it, they listed it twice. Here's our new options. New option 1, or new option A, and then new option B. We have to decide whether the size of the new menu is similar to the original menu. And if so, we write a similarity statement, determine the scale factor, explain your reasoning. So we need to decide, is A the similar one, or is B the similar one, or is it neither? Okay, if I do 12 from the original, what number do I need to use from the new? 14, so that reduces to 6 over 7. So I'm thinking the scale factor is 6 over 7. I need to check with the other side, 10 over 12. Oh no, that reduces to 5 over 6. Since we didn't get the same number, the sides do not have the same scale factor, so no, menu's not similar. If we try the same logic with the bottom one, so we do 10 over 8, and we get 5 over 4. And then if we do 12 over 9.6, I'm not really sure what that is as a fraction, but if you want to, you can type them both in your calculator and get the decimal. I know 5 over 4 is 1.25. I need to know what 12 over 9.6 is. It is also 1.25. Since we got the same number, that's the scale factor, and the menus are similar. I know the directions said to write similarity statement and all that jazz, but I'm going to stop there. But if they ask you for the scale factor, it's obviously 1.25. Okay, we get to the next three, and it says, determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. If not, explain your reasoning. Okay, so first thing I do is I check the angles. 59, 35, 59, 35. Do I know that B and E match the angles? Yes, because it's a triangle, and we know that if two of them match, the third one has to match, because they all have to add up to 180. Okay, so I can try to write, figure out the scale factor. If I use 6 from the left one, I need to use 4 from the right one because they were both next to the 59 angle. That reduces to 3 over 2. If I use 9 from this one, I need to use 6 from that one, and that also reduces to 3 over 2. And then last but not least, 10.5 over 7, and I need you to type that into your calculator. If it is 1.5, because that's what 3 over 2 is, the decimal 1.5, then I know we have similar triangles. Tilly, is it? Okay, I thought so. Okay, so this number, you can use 3 over 2 or 1.5. That is our scale factor. Since we got it for all three sides, we do have similar triangles, and we found the scale factor. We need to write a similarity statement. So triangle ABC is similar to triangle, and then again the order matters. So I have to do D, then E, and then F. The order matters. So this is what you're going to do. We'll come back to it in a second. Let me go on my side rant. This is how you could blow this on the test. You cannot write your similarity statement correctly. That would be the most common mistake. The mistake that most people would make. What might happen is that you might compare wrong. You might do 6 and 7. For instance, it'd be really easy to mess it up on number 3. I want to do 8 and 6 because they were both the left numbers I see, but we can't do that. We need to make sure we're putting them in the correct order. And then the last thing, which is the most common mistake, is that we can flip it. So Joshua's on a roll. He did 6 over 4, he did 9 over 6, and then he gets to the last one, and instead of doing 10.5 over 7, he does it reverse. He does 7 over 10.5. He gets the flipped. He gets 2/3 as the scale factor. He had 3 halves, then he has 2/3. So he says, no, they're not similar. And all because he wasn't being meticulous with his work. Are there any questions about that? So it is easy, but it's also easy to mess up. Okay, I'm going to fly through the next one if you don't mind, so you can get to work today. 16 goes with 24 because they're both between the 1 and 2 rainbows. That reduces to 2/3. So Alex has already blown it if he did 12 and 24 instead of 16 and 24. 12 needs to go with 18 because they're both near 1 rainbow. That reduces to 2/3. And then 14 with 21, that also reduces to 2/3. So our scale factor is 2/3. Yes, you do have to check all 3 sides. We need to write us a statement. So I'm going to say triangle. If I do ABC, then the other triangle has to be UVT. Again, the order of the letters matter. Okay, and I think you have the hang of this, so I'm not going to make us do the last one. But again, if you think 12 and 6 go together, good grief, 12 and 6 do go together. Make sure you're putting 4 and 6 together. Make sure you're comparing the right sides. Okay, so you would like to know what on earth we're doing next, Wisconsin, because I didn't hand it to you. So I'm about to fly through these last couple examples, and I mean fly. The back 6 are your homework. It has to be done tonight. We have to move on to 7th week tomorrow. We've already talked about we're behind, and the way we can make up for that is to move quickly through chapter 7, because chapter 8 is a beast. Fun is a beast. Okay, when I said I was going to fly through these, I literally meant fly. Before I get started on flying, we need to correct number 6 on your worksheet. Instead of being x plus 2, make it a y plus 2. On the back side on the worksheet on the bottom, instead of x plus 2, make it y plus 2. Okay, then flip to the front. You know, now that you've got it down, what we always seem to do in geometry is once you really start to understand something and you think you can do it, we throw in variables. But the good news is, in this section at least, throwing in variables makes the problem even easier. You're already told they're similar. We just have to play rainbow match. So I need to do y plus 1 equal to some number. Do I use 6 or do I use 8? I use 8. I'm looking at rainbow match. So y plus 1 equals 8, so y equals 7. Are there any questions about that? Okay, and then I need to do x equals something. Do I use 4 or do I use 3? I either got to use 4 or 3. 3. Or at least that's what I wanted to do, and I've done this problem entirely wrong. I need to fix first period now. Erase all that. That's wrong. Why is it I'm blowing first period, and then when I see y'all, I suddenly recall how to do math? I'll just do new paper. Well, we told they're congruent. We're told they're similar. Golly, I gotta fix first period now. Bless their hearts. It happens. I see there's a 6 here. And that needs to go with the 4. So the scale factor is 3 over 2. Everyone okay with that? I put SF for scale factor. I was being lazy and didn't spell it out. So I know x, yes, x and 3 are supposed to be similar. So I'm going to do x over 3. But I'm going to set it equal to that scale factor, which was 3 over 2. I cross multiply, I get 2x equals 9, so x equals 4.5. I know I was trying to make things way easier than they were. I knew there was a catch. And this is why we learned how to cross multiply last section. Are there any questions about what I did in pink? I need to do it again with the other sides. So 8 over y plus 1 equals my scale factor, which was 3 over 2. When I cross multiply, I'll have 3 times y plus 1 equals 16. So I have 3y plus 3 equals 16. 3y equals 13, and I'm out of room. Y equals 13 over 3. Are there any questions about that one? I hate when I do things wrong. Yeah, I didn't do that. I mean, I hate that I messed up first period. Suddenly I see you and I'm so much smarter. I'm not going to do 4, 5, and 6. I'm only going to do 5 to prove a point again. If I do 40 over 30, because of those numbers don't have any x's or anything, 40 over 30, I get 4 over 3. That is my scale factor. So x plus 15 is supposed to go with 18. So x plus 15 over 18. And I set it equal to that number that was my scale factor, which is 4/3. I can then cross multiply and solve. So 3 times x plus 5 equals 72. So 3x plus 15 equals 72. 3x equals, I don't know, 17 minus 15. $72 minus 15. Sorry, dears. 63? 60, 57?
15, yeah, 45, x plus 15.
3x plus 15. So I subtracted 15 from both sides. What's 72 minus 15?
57.
So 3x equals, so x equals whatever 57 divided by 3 is.
No, you put x plus 5.
And it's supposed to be x plus 15,
Yeah.
and that's supposed to be a 45.
Yeah.
So 3x equals what number? Thank you. When you're hot, you're hot. When you're not, you're not. So then x equals 9. That makes so much more sense. Thank you, Elena, and all the others. My gosh. You have 6 on the back. You're welcome to work. I'm going to show people their test grades. If I ever get that done, I'm going to go back to the checkpoint. If you somehow lucked out and didn't have to do the checkpoint last week, it's still happening either today or tomorrow. So you didn't look out that much.